In this lecture of vectors, we are solving few remaining problems of exercise 5.2. Question number 6 is D and E divide sides BC and CA of a triangle ABC in the ratio 2:3 respectively. Find the position vector of the point of intersection of AD and BE and the ratio in which this point divide AD and BE. So I understand that I need to first draw the triangle ABC. So here I draw triangle ABC. So ABC. It is said D and E divide side BC and CA of a triangle ABC in the ratio 2:3 respectively. So what does that mean? D and E divide BC and CA. So D divides BC, E divides CA. D divides BC and E divides CA. So D divides BC. So D is on BC and E is on CA. How does that divide? How do they divide? They divide in the ratio 2:3 respectively. So D divides BC in the ratio 2:3. D divides BC, see the order, in the ratio 2:3, and E divides CA in the ratio 2:3. This is important. So dB upon DC, dB upon DC is 2/3, and EC upon EA is 2/3. Okay. So here, see, so D is on BC such that D divides in the ratio 2:3. So this is 2 and this is 3. And E is on CA such that E divides CA in the ratio 2:3. E divides CA in the ratio 2:3. So this is 2 and this is 3. This is important, don't write 2 here and 3 here. See the order. E divides CA. So you have to write C to E as 2 and then A to E as 3. So further they say, find the position vector of the point of intersection of AD and BE. So now join A with D. Join A with D. And then join B with E. Find the position vector of point of intersection of AD and BE. So let these two divide each other at point A, B, C, D, E. Let the point be F. Let them divide each other at point F. So we have to get the position vector of point F. Okay. See, how do I do it? I will write, okay, I have to get the position vector of point F and the ratio in which this point divides AD and B. And you also have to find the ratio in which F divides segment AD and segment BE. That is, you have to find this ratio. AF upon DF, also BF upon EF. Okay, we have to get this ratio. So let's begin. I will write here, let A bar, B bar, C bar, B bar and E bar, B bar and E bar, E bar be the position vectors of points A, B, C, D and E respectively with respect to O. Respectively with respect to O. That is origin. What is O? O is the origin. Origin. Now, so I also write Therefore, see, this is, as you know, we don't have to show these position vectors in beside point A. Beside this point A, I will write A bar. Here I write E bar, and this is C bar. Okay. So I will apply the section formula, internal division section formula on AC. Look at AC. Look at the vector. Look at the segment AC. Look at this AC. I will apply the section formula on AC. What do I notice? I notice that point E divides AC in the ratio 3:2, or E divides CA in the ratio 2:3, whichever way you say. Okay, so I will write bisection formula. I write here bisection formula. Bisection formula. See here, E bar equals to 2A bar. See, this 2 will multiply A and 3 will multiply C. Okay, so 2A bar plus 3C bar, 2A bar plus 3C bar upon 2 plus 3. 2 plus 3 is 5. So I get here 5E bar equals to 2A bar plus 3C bar. So if you are surprised that why I multiplied this 5 here, so for that I will tell you, listen carefully. They are not asking us the position vector of point E. They are not asking us the position vector of point E. Though they have given that E divides segment CA in the ratio 2:3, they are not asking us the position vector of point E. What they are asking us is the position vector of point F. Okay, so you will have to understand that what am I doing here? See, we are not solving for E or D. Though we are given that these points are dividing, we are not working for E or D. We are working for F. Now, how do I go there? You will understand in a while. You will understand that in a while. So here, this is equation number 1. Now, after this, I write here bisection formula. Bisection formula, I apply for D. So here what we have D bar. I'm sorry. We have here D bar. This is B bar and this is C bar. Okay. So D bar equals to, what do we have? D bar equals to 2C bar plus 3B bar. 3B bar upon 2 plus 3. So again, what we will have here is 5D bar equals to 2C bar plus 3B bar. Okay, this is number 2. Okay, now check this. You know, this point F, if you want to reach point F is the intersection of AD. You see this? Point F is intersection of AD and BE. AD and BE. It is intersection of AD and BE. So from these two equations, which I am having here, which two equations? Here. Okay. From these two equations, I must try eliminating point C. Okay, point C. Because see, I want to incorporate these points, you know, A, D, B, E, A, D, B, E. Okay, because it is F, the point F, whose position vector I want. It is intersection of AD and BE. It is intersection of AD and BE. So I must somehow incorporate AD, BE. I should have these position vectors, A bar, D bar, B bar, E bar. and I should avoid this C bar. But then here what I notice, C bar is there, you know. So see, how do I eliminate it? So I write here multiplying multiplying 2 multiplying equation 1 by 2 and equation 2 by 3 throughout. So when you multiply equation 1 by 2, so you get 10 E bar equals to 4A bar plus 6 C bar. I write this as equation 1A. Okay. And here you get 15 D bar equals to 6 C bar plus 9 B bar. This is 2A. Now subtract. So when you subtract, you get here minus, minus, and minus. So this cancel. You get here 10 E bar minus 15 D bar equals to 4A bar minus 9 B bar. Okay. So I'm working on these two. I'm working on AD and BE. You got that? AD and BE. So if I'm working on AD and BE, what should I try? I should try to get A bar and D bar together. You see this? A bar. I should try to get A bar and D bar together, E bar and B bar together. You understand? So here I write here, therefore 10 E bar plus 9 B bar. 10 E bar plus 9 B bar equals to 4A bar plus 15 D bar. 4A bar plus 15 D bar. Okay. Now, this is what I have. See, the next what I do is I write dividing. I write here dividing throughout by 19. That is both sides, dividing both sides by 19. Instead of writing throughout, I should have written here both sides. Dividing both sides by 19. So see, I get here 10 E bar plus 9 B bar upon 19. Can I write 19 as 10 plus 9? And here 4A bar plus 15 D bar upon 19. Can I write it as 4 plus 15? Yes. What I do now is, see, I notice, look at this equation. This equation, I write it as 3. From equation 3, I understand the left-hand side of equation 3. Check the left-hand side of equation 3. What is it? Observe this minutely. What is it? It is position vector of a point. It is position vector of a point which divides segment EB or BE, which divides segment BE internally in the ratio 10:9. Okay. So if you're thinking, how is this? I'll tell you. You remember In the beginning, I had told you that if you have here A, B, and somewhere you have point P, and the ratio is m is to n. So for this diagram, what is the statement? For this diagram, what is the statement? The statement is point P divides segment AB, internally. P divides AB internally in the ratio. What ratio will you write? You will write m is to n. And what is the formula then? You write the formula P bar as MB bar plus NA bar. See, this is B bar here. This is A bar here. So MB bar plus NA bar upon M plus N. Okay. So there are three things here that we follow. The diagram, the statement, the formula. Remember, from any of these three things, the other two you can derive. The other two you can get. You can get the other two. For example, if I have, see, how could I write the statement? Because I saw the diagram. How could I write the formula? Because I saw the diagram. The same way, if I have the statement, can I draw the diagram? Yes. And can I write the formula? Yes. Likewise, if I have the formula, I'll be able to write the statement and draw the diagram. So look at the formula. The formula here is P bar equals to, what is P bar? Look at the formula. P bar is MB bar plus NA bar upon M plus N. So when it is MB bar plus NA bar, you say P divides AB. You say P divides AB, you say P divides AB in the ratio M is to N. So if it is AB, the ratio is M is to N. So when you are saying the segment as AB, while writing the ratio, you go the other way. AB, so the ratio is M is to N. And if you had said BA, if you had said segment BA, then you would say the ratio as N is to M. Okay. So here, what do I say? I say this is position vector of a point, which divides segment BE internally in the ratio. What ratio will I say? In the ratio, see, I said BE, so the ratio I would say 10 is to 9. Okay, I would say the ratio is 10 is to 9. 10 is to 9. Okay. And for the right hand side, what I understand that this is position vector of a point. Okay, look at the formula. Look at the structure of this RHS. RHS is in what form? It's in the form MB bar plus NA bar upon M plus N. Okay, so I would say here that this is position vector of a point which divides AD in the ratio 15 is to 4. Okay, so having said that, see what we will do the next. I will write here the LHS of 3 is position vector of a point which divides segment BE internally in the ratio 10:9. The RHS of 3 is position vector of a point which divides segment AD internally in the ratio 15:4. So 10:9 and 15:4. You understand? Now what I further notice is that these two are equal. It means these two represent one single point. See, this position vector is equal to this position vector. It means these two position vectors represent one single point. And what is that single point? That single point is dividing BE. Look at this, what you wrote. You wrote it divides BE, okay, and you wrote it divides AD. It means this point is dividing both the segments. It means this point is the intersection of BE and ED. This point is intersection of BE and ED. What does that mean? It is this point. It is this point. See, it is this point. It divides AD in the ratio 15:4. 15:4. And BE in the ratio 10:9. 10:9. BE in the ratio 10:9. Okay, so here I write here from 3 we can say that the position vector of point of intersection of AD and BE is F bar equals to 10 E bar plus 9 B bar upon 10 plus 9 equals to 4 A bar plus 15 D bar upon 4 plus 15. Also, the point F is point of intersection of AD and BE. Dividing them internally in the ratio 15:4. 15:4 and 10:9 respectively. This is another very simple question from same exercise 5.2. And what is it? It says if two of the vertices of the triangle are A314B minus 4, 5, minus 3, and the centroid of a triangle is G minus 1, 2, 1. Centroid of the triangle is G minus 1, 2, 1. Then find the coordinates of the third vertex C of the triangle. So what is the triangle? The triangle is ABC, and they give us two of the vertices of the triangle. A, B, C is the triangle. They give us the two of the vertices. That is, they give us A. The coordinates of A and B are given. They say A is 3, 1, 4, B is -4, 5, -3. What more is given? We are given the centroid of this triangle. The coordinates of the centroid is G. The centroid is G and its coordinates are -1, 2, 1. The question demands, then find the coordinates of the third vertex C of the triangle. So we have to find the coordinates of third vertex. I will write this as ABC. Okay. You can write ABC or you can write x1, y1, z1, whatever. X1, y1 and z1. So here I start writing the solution. I write let C be x1, y1, and z1. Now we apply centroid formula here. We know the x coordinate of centroid of a triangle is sum of all the x coordinates divided by 3. I write here by centroid formula. By centroid formula of a triangle. So what do I have? See the centroid, the x coordinate of centroid is sum of all the x coordinates of the vertices divided by 3. So what do I have here? I have here -1 equals to 3 plus -4, 3 plus -4 plus x1 upon 3. So you have -3 equals to -1 plus x1. So x1 equals to -2. What is x1? -2. Then I go for y1. You cannot write the formula for y1. You will write formula for y coordinate of centroid, and that will get you y1. So here you write 2 equals to 1 plus 5, 1 plus 5 plus y1 upon 3. So 6 equals to 6 plus y1, and you get y1 as 0. What is y1? y1 is 0. Then you have to find z1, and z1 you will get when you'll consider the z coordinate of centroid. You write 1 equals to, this is 1. So 1 equals to 4 plus -3, 4 plus -3 plus z1 upon 3. So 3 equals to 1 plus z1, and z1 equals to 2. So we got x1, y1, z1. Therefore C is -2, 0, 2. Very simple question. You can copy this. Another question is number 11 from same exercise 5.2. It says, if the centroid of a tetrahedron OABC is 1, 2, -1. So the tetrahedron is OABC. Okay. So here we have OABC. Let me have this as This is tetrahedron. This is the tetrahedron. And the tetrahedron, it has got four. This is the edge which is on the other side. So I draw it dotted. Okay. So this is ABC, A, this is C, this is B, and here you have O. So B is on the other side of triangle OAC, you know. So here you have a tetrahedron. O, you know, is 0, 0, 0. Then the coordinates of A are A2, 3, B are 1, B2, and C are 2, 1, C. They say the centroid of this tetrahedron, the centroid of the tetrahedron is 1, 2, minus 1. So centroid of the tetrahedron. So this is, I write G, 1, 2, minus 1. I write here, let G be the centroid of tetrahedron. I write by centroid formula. By centroid formula in a tetrahedron. In tetrahedron. Now I know that x coordinate of tetrahedron, x coordinate of centroid of tetrahedron is sum of all the x coordinates, sum of x coordinates of all the four vertices divided by 4. So positive 1 equals to, what is positive 1 equals to? It is 0 plus a, 0 plus a plus 1 plus 2 upon 4. So you have 4 equals to a plus 3 and a equals to 1. A equals to 1. So I got a. Then I will go for another centroid, the y coordinate. 2 equals to, add all the y coordinates. 0 plus 2 plus b plus 1 upon 4. So 8 equals to b plus 3, b equals to 5. And finally, we have the z coordinate of centroid. So negative 1 equals to 0 plus 2 plus 3 plus c upon 4. So negative 4 equals to c plus 5 and c equals to negative 9. So we got the value of ABC. The question doesn't end here. The question further says, find the distance of PABC from the origin. Now using these numbers A, B and C, one point is defined in the space. So the point is ABC, that is 1, 5, minus 9. Okay, so I will have the point here 1, 5. So P here, you know, somewhere P will be there. And what will be the coordinates of P? The coordinates of P will be 1, 5, negative 9. Okay, and we need to find the distance of P from origin. Distance of P from origin. You know, distance of any point from the origin is the square root of sum of squares of x, y, and z coordinates. So here I will write, okay, OP equals to square root of 1 square plus 5 square plus negative 9 square. that is equal to 1 square is 1 plus 25 plus 81. 1 plus 25 plus 81. How much is this? This is 82, 87, 97. Square root of 97. This is the distance of P ABC from origin. So what you did in this, first you use the tetrahedron centroid formula. Using the centroid formula for tetrahedron, you calculated the value of ABC, and after that you defined a point P ABC in the space and you calculated its distance from the origin. Okay, this is the end of this problem. Simple problem. In question number 12, we have to find the centroid of a tetrahedron with the vertices. They give us the vertices of a tetrahedron K, L, M, N. What do they give? They give the vertices of the tetrahedron. And we have to find the centroid of this tetrahedron. It is very simple question. What will you do? Okay, you can assume, see, these numbers are given to us. K is 5, -70. L is 153. M is 4, -63. And N is 6, -42. We have to find the coordinates of centroid. So I will assume let G be the centroid of the tetrahedron. Now we know the x coordinate G and x1, y1, z1. Let that G be x1, y1, and z1. So what is x1 equals to? X1 will be add all the x coordinates of this vertices. For the x coordinate of centroid, what you will do? You will add all the x coordinates of the vertices, divide by 4. So 5 plus 1 plus 4 plus 6 by 4. That is equal to 16 by 4. And that is equal to 4. So x1 is 4. Similarly, you will calculate y1 and z1. Okay, that's the end of this question. We are left with one or two more problems in this exercise, which I will take in another video. Thank you.